I've been asked to make a video on algebraic division or algebraic long division, so I'll make a video on algebraic long division. So let's say we wanted, I'm just going to make up a problem. Let's say we wanted to divide, we wanted to see how many times does, I'll start with a fairly straightforward problem. How many times does 2x plus 1 go into, I don't know, let's say it's 8x to the third minus 7x squared plus 10x minus 5. So what we do is we just take, actually just the exact same way that you would do with long division, traditional long division of multiple digits. You would, on the 2x plus 1 expression, you look at, what is the highest degree term? And that's really all we're going to pay attention to most of the time. So the first step is you say, the highest degree term is 2x. How many times does 2x go into the highest degree term of the number, or not the number, the expression that we're dividing into? So you say, how many times does 2x go into 8x to the third? Well, we could do a little division on the side, but you could imagine eventually this is pretty straightforward. So if you have 8x to the third divided by 2x, that is equal to 4x squared, right? So 2x goes into 8x to the third 4x squared times. And this is a key thing. You don't want to write the 4x squared here. You want to keep everything in the correct places. So when you're dividing numbers, you think of the ones, the tens, the hundreds, and the thousands place, etc. When you're dividing polynomials, you can kind of think of the x to the 0 space, the x to the 1 space, or the x space, the x squared space, the x to the third space. So when we say that 2x goes into 8x to the third 4x squared times, let's write that in the x squared spot. So it goes into it 4x squared times. Now, we take that 4x squared and we multiply it by our expression. I think you're already seeing that this is very similar to long division. And actually, if x was a 10, it would be identical to long division. And I'll let you think about that, right? If x was 10, this would be the thousands place. This would be 8,000 minus, although you would have negative digits, which doesn't make a bunch of sense. But I think you get what I'm saying. But anyway, back to this algebraic long division. Although I think it is very important to see the parallels between this and traditional long division. But anyway, we said that 2x goes into 8x to the third 4x squared times. Now what we can do is we can multiply 4x squared times 2x plus 1. So 4x squared times 1, that's 4x squared. So we can write that in the x squared place. We could write it 4x squared. And 4x squared times 2x is 8x to the third. 8x to the third. This is a plus here. And now, just like we do with traditional long division, we can subtract this from this. So minus 7x squared minus 4x squared is minus 11x squared minus 11x squared, and then 8x to the third minus 8x to the third is 0, so we can ignore that right there. And if we want, we can bring down the rest of the number, but maybe just for fun, we'll bring down the next spot, just like we do in traditional long division. And actually, let me erase this over here. Let me erase this because I think we might find that real estate useful. All right, I'm back. Actually, it doesn't hurt to bring down the whole thing, just so that you understand what we're doing. We're saying if you were to divide 2x plus 1 into this entire expression, and you say that it goes in 4x squared times, now you could kind of call it our intermediate remainder is what's left, right? This is what's left. You could almost imagine 4x squared times 2x plus 1 is 8x to the third plus 4x squared plus 0 plus 0, right? Because it doesn't contribute anything to these spots. But then what's left over is this expression. If you take this minus this whole expression, you get what's left over. Now we just do the same thing over. How many times does 2x, we just look at the highest order term, how many times does 2x go into negative 11x squared? So let's do something, let's write it here on the side again. Actually, let me do it here. So if we were to take minus 11x squared divided by 2x, that is equal to what? That is equal to minus 11 halves x, right? So 2x goes into minus 11x squared minus 11 halves x times. So we'll write that in our x place. So minus 11 halves, we could write that as 5.5 if that, well, let's write it as a fraction. Minus 11 halves x. And now, what is minus 11 halves x times 2x plus 1? So minus 11 halves x times 1 is minus 11 halves x, and we'll want to write that in the x position. I'll switch colors just to not be monotonous. So minus 11 halves x times 1 is minus 11 halves x. And then minus 11 halves x times 2x. Well, we should know what that is, but if you could multiply them out, it'll be minus 11x squared. Minus 11x squared. And I think you see what we're doing. After every step, we're canceling out the largest degree of the polynomial we're dividing into. Fair enough. Now let's subtract this expression from this, and we'll get kind of our new intermediary remainder, and maybe that'll be the full remainder. So let's see. Minus 11x squared minus 11x squared, that's 0, so we don't have to write anything there. 10x minus negative 11 halves x. So remember, we're subtracting this negative number from 10x. So if you're subtracting a negative number, it's like adding a positive number, right? So you could view this as 10 plus 11 halves, right? So 10 plus 11 halves, that's 20 halves plus 11 halves, that's 31 halves, or 15.5. I'll just write 31 halves x. 31 over 2x. And then you could say that there was a 0 here, and when you subtract 0 from minus 5, you get minus 5. And now we say, how many times does 2x go into 31 halves x? Let's do a little work on the side here. So if I have 31 over 2x divided by 2x, well, the x's will just cancel out, right? And so this is the same thing as, this is equal to 31 over 4, right? This is the same thing as 31 over 2 times 1/2, so it's 31 over 4. So 2x goes into this expression 31 over 4 times, and I'll switch colors. I'll switch to green. So, and that's a positive, right? You're dividing a positive into a positive. So plus 31 over 4 times, and I'm writing that in the, you could view that in the constant space, or in the x to the 0 space, or the 1 space even. So it goes into 31 over 4 times. 31 over 4 times 1 is 31 over 4. 31 over 4. And 31 over 4 times 2x is 31 over 2x, right? 31 over 2x. And now we subtract, this is a plus here, we subtract the green expression from the light blue expression. And we're left with this. When you subtract this from this, you're left with 0, so nothing shows up there. And we're left with minus 5 minus 31 over 4. And we can just do a little bit of fraction work here. That's equal to, see, minus 5 over 4 is minus 20, minus 31, all of that over 4. So so that is equal to what? Minus 20, that's equal to minus 51. Minus 51 over 4. So our answer is 2x plus 1 goes into 8x to the third minus 7x squared plus 10x minus 5. It goes into it 4x squared minus 11 halves x plus 31 over 4 times. But there is a remainder, and this is the remainder. And so a way to visualize this, or another way to think about this problem, just so that we don't, so it's actually useful when we're actually solving real problems, and that you just don't view this as some kind of mechanical way to get problems right on a test that only tests algebraic long division. As another way to write this relationship, you could write that, let me do it in another color. Let's see, I've used many of my colors already. So you could write that 2x plus 1 times this 4x squared, that's an x, minus 11 halves x plus 31 over 4 plus the remainder. So when you multiply these two out, and then if you were to add the remainder, 51 over 4, that would equal, and let me draw a dividing line. I don't want to confuse you with all this stuff here. That would equal this. That would equal 8x to the third minus 7x squared plus 10x minus 5. Anyway, I hope that helps. See you in the next video.